Hello everyone. So as I mentioned in the email I sent just before, it seems there will be very heavy snow in Pennsylvania in the eastern part, the east coast of the United States. So as you might see in the news, there are so many states affected by the very heavy snows, canceling all the classes, and roads are covered a lot of snow. So there was the outage of the electricity and the water and the internet. These are expected in some areas around here. So we are not sure, but I decided to keep our class time, maybe the shorter than the regular class time, but I decided to prepare the asynchronous lecture video so that you can review and then you can prepare for the next week's classes. So this lecture will be used as a replace of the synchronous lecture, but will be kept as asynchronous one. So you are expected to watch and then see what will be covered in next week. But because next week on the any other incremental weather issues are not expected yet, so probably we will come back as a synchronous one. So just for the lecture for Thursday, I'm just keeping it as asynchronous. So that will be my plan. So let's cover. So this is the first part of the video because we will be covering more about the z-score. So I mean the z-score is using the normal distribution, and that will be very closely relevant with the question number one, and yeah, I think the question number one in the lab assignment two. So as I mentioned in email as well, the the new due of the lab assignments will be Friday. So all the following assignments will follow the same the due date. I mean the same the intervals of the due dates. So as one assignment is the extended to the Friday, it means that the next assignment, I mean the lab assignment three, that will be due on the following Friday. So anyway, the due of the lab assignments will be every Friday from now on. So that's the changes I will make. Sorry. All right. So let's make some the backup and so because I couldn't finish something on this Tuesday, so I will cover a little bit more about the basics of the z-score so that you can do more about the question number one and in the assignment and maybe probably question number three in the lab assignment too. So let's start. All right. So this is the distribution, the normal distribution, the Gaussian normal distribution, which is showing. Oh, let me a little bit down. Okay, I got it. So a little bit of the hypothetical one because the mean is 0 and the standard deviation is 1. So you can know that there are the rule of the 68, 95, and 99. So this is the very basics of the distribution. And let's ask this question. If there is some student, so if there is a student who has the math score as a 95 out of 100, so what would be the answer? Maybe yes, or maybe no, or maybe don't know. So in common sense, having the 95%, it means that out of 100, she or he got the 95 out of 100. So usually in the common sense, it might mean that she or he is very good student in general. However, is this high score in that setting, in that situation? Probably we don't know about that because so there would be the two settings, two possible situations. So even though the math score is the same as 95, this is the one sample of the distribution that the math score, the mean math score is just 20. So it means that if the student got 95 averagely when the student got the 20, that means the student is kind of super genius, very genius because the averagely, the most of the cases are around the mean. But the student got the 95 as the score. So that's very, very big. That's a very good student in general. However, if the student is in the very super, the full of the genius is there. When the mean math score is 99, 95 is a relatively not very good score in that school or in that classroom. So if we just know about the specific score as a low score, we cannot know that that score is very good in that group or in that situation. So in this case, we can make a standardization. So we can create the z-score as a standardization, and maybe we can check the relative, the place, I mean whether that is good or not, whether that is high or low, big or small in that meanings of the magnitude. We can change that math score, I mean the raw score or original score, to the standardized score as the z-score to see whether the score or whether that value is high enough or the low enough in that terms of the comparison. So let's see how to do that. So the z-score is based on the normal distribution, and then the z-score is calculated by the number, some specific number. So we are changing some specific number. So previously we had 95 as a score of the person, and this is the population mean. So you may see that we are just assuming that we know about the population mean and population standard deviation. So x, which is the specific score, minus mean or average divided by the standard deviation. That is the equation. We can calculate the z-score based on the sorry, I still have the coughing symptoms. And that's how to calculate the z-score based on the mean and the standard deviation of the group or the population data. So mean of the z-score is 0, and the standard deviation of the z-score is 1 every time because it's based on the normal Gaussian distribution, and that is theoretically tested as the general rule. So the higher z-score, means that the higher z-score, like 1, 2, 3, 5, 4, 5, it means that that score or that value is on the top of the distribution. If the z-score is negative numbers like -1, -2, 3, 4, that means that that value or that case is on the bottom, on the very bottom of the distribution. So higher z-score means the higher or bigger or better or more excellent compared with other scores in general. So the bigger z-score means they are on the top of the distribution. So let's make an example. So which student has the better score at their school? So by using the z-score transformation, we can know where that score or that case is placed in terms of the distribution, whether very top or the bottom or the very middle or relatively the higher or the lower distribution. So student A, she has a GPA as 3.5, maybe 3.5 out of 4.5. That's not a big matter. So she has the score as 3.5, and the mean GPA, I mean the mean is 2.5, and standard deviation is 2. So you can calculate the z-score of this person or this student, and then student B, he has the higher GPA in terms of the absolute value or the raw score, but the GPA of that school, I mean the school B, is 3.8, and the standard deviation is 1. And then if we compare the z-score of the student A, the girl here, and also if we calculate the z-score of the student B, and then we can compare those two z-scores, and then we can know that whether the girl student has the higher or placed in the higher score length in that school, or maybe it's the boy student has the better score in that school. So we can compare the z-scores. So the calculation is it can be done in this way. So GPA here 3.5 is the x in that in this equation, and then 2.5 is the mu as the mean. Standard deviation is 2. So after plugging in that number, you can calculate the z-score of the student A. So 3.5 minus 2.5 is the mean, divided by standard deviation 2. So you are just plugging in the numbers, plugging in those numbers in that equation. So z is 3.5 minus 2.5 divided by 2. So the z-score of the girl is 0.5. So in that school, maybe maybe less than within 1 standard deviation, so we can know the relative position of the girl student in that school. So after that, in the same way, you can plug in the number 4.0 as the x, and then 3.8 as the mu, divided by standard deviation. So 4.0 minus 3.8 divided by 1 is 0.2. So let's compare those two z-scores. So as the girl, so student A has the higher z-score. We can know that. So we don't know whether the school A is the better school or not. But anyway, the student A has relatively the higher position. I mean, the better position in the school A compared with the position in the B. Because you can know that the mean of the school, there is 2.5 in the school A and 3.8 in the school B. So even though the GPA is higher for the student B, student A has the higher rank or higher position because she has the higher z-score. So maybe you assume that student A might have the better rank, I mean the higher position or higher rank, doing better in that school in the school A compared with the student B in the school. So we can compare the z-score in this way. So let's compare. So let's calculate the Dave's z-score of his height. So that group, so hypothetical group mean is 5.8 and the standard deviation is 1. So in that case, what is the z-score? What is the Dave's height, right? So that will be a little bit application of the equation because we already know about the z-score here. We already know about the z-score here, and then when we know about the group mean and the standard deviation, it means that the x, so the x in the equation, the x in the equation is not decided because we don't know about that. So we can plug in the equation to calculate that. So z-score is here, so 2.5 is x minus 5.8 divided by 1. So this is the equation we are using, okay? And then 2.5, so negative 5, the minus 5.8 is moved here, and that will be 8.3, which is x. So maybe very unrealistic, but David's height is 8.3 feet in height. So I know that might be very unrealistic, but this is the way how to calculate that. So based on the equation of the z-score, sometimes when we don't know about one number or one part of the equation, we can use or we can plug in those numbers as z, mu, or standard deviation as to find those numbers in terms of the z-score and the distribution. All right, so let's compare. So let's see one more example. So one more example here. For example, let's suppose that my stat exam score is 900 out of 100, and then the mean stat score is 85. So the mean of the schools or the classes stat score is 85, and then standard deviation is 5. And let's suppose that the population size is 100. I mean, there are the 100 students in the school. And then the question is, how many students have higher stat score than me? Right? So as we practiced last in the class in my lab and in the previous class on Tuesday, we can know that the population, so the population multiplied by the proportion, that will be the number of cases in that proportion. For example, my stat score is here. My stat score is 90, and the top score, the maximum score is 100. So how many cases are in this shaded area? That will be on the goal of this question. So mu, the population mean, is 85, and the standard deviation is 5. And the variance is 25. If you're square root that will be the standard deviation, so that will be 5, as I indicated here. All right, so the z-score can be calculated. So z-score is 90 minus 85. So 85 is the mean, and my score is 90. So 90 is here in x, 85 is the standard, the mean, and 5 is the standard deviation. So we can know that 1 is the z-score of my score, right? And this shaded area, let's calculate this shaded area. So this is the 1, and we are just finding this area. The shape. So under this, the shape, it means that 100% of the cases are in all under this curve, which means that 100% will be 1 in the proportion. So when you have the one cake, 1 is the maximum number when you have. And if you have the half of the cake, that will be 0.5 cake. And if you have just the quarter of the cake, that will be 0.25 cake. So that will be on the way of the saying. All right, so area below my z-score, that will be, so because this is the symmetric distribution, so I'm talking about so a little bit very important one from now on, so please focus on my explanation. So this is the shape of the distribution, and which is very symmetric here. And just half. We are just calculating this part. So this part will be calculated as the proportion, and this half is 0.5, right? So we already know this part is 0.5. And then we already know that 0.341 is this part, right? It means that below my score, so my z-score, the z-score of my stat score is 1 in here, and below that line, so this area is 0.5 because that's the half of the 1, and that is 0.341. So from total, so that is a 1. So under all the normal Gaussian curve, that is 1 because there is 100% of cases. So that will be 1 out of the total minus 0.5 here and 0.34. So that will be in total as a result 0.16. So we can know that this shaded proportion, maybe you can see in this shaded proportion, that will be only 0.16. So we know the proportion, right? So that will be the number of cases in the population multiplied by the 0.16. So the result is 16. It means that there are 16 students over my score. So that will be maybe 15. So including me, there will be 16 students above my score. So that will be the example of the calculation. So maybe including me 16, maybe we could say the 15 students over my score, but let's see. Let's just assume that there will be the 16 students, be including me. So that will be the better answer, but not a big difference here. So because we are doing the synchronous one, so maybe we cannot use this as in-class practice. But when the mean is 90 and the standard deviation is 10, x is 100. I mean, my score, the low score is 100. So what is the z-score? You can easily calculate that in terms of the maybe let me just cancel the and because I want to use the annotation. So maybe I can make it larger. Okay, so in this case, we can try to calculate, right? So in the equation, x minus mean divided by, so maybe because there's on the parentheses, so on the numerator is here and the denominator is standard deviation. So it means that 100 minus 90, which is the mean there, divided by standard deviation, which is 10. So that will be 10 divided by 10. So that will be in 1. So the z-score will be 1. Okay, that's very simple there. The calculation will be very simple. When the z-score is 1, z is 1, so I'm just doing the question number 2 here. When the z-score is 1, and the standard deviation is 5, and the mean is 80. So what is the x? So we are plugging in the same calculation like this. So we already know that the z-score is x minus mean divided by the standard deviation. And in this equation, we know that 1 is my score minus mean 80 divided by standard deviation. All right. So because this is just a division, you can multiply 5 on both sides to cancel the division of the 5. So maybe in this way. Okay. So it's a little bit more mathematics, looks like more mathematics, but multiply 5, multiply 5. So we multiply the same numbers, so that will be fine. And this one cancels the division of the 5 here. So x minus 80 is 1 multiplied by 5 is 5. So that will be 85 is the my score x. So x is 85 in question number 2. So regarding the respondent A and B income, A's z-score is 3 when the mean is 500 and standard deviation is 70. And B's z-score is 5. So when the mean is 400 and standard deviation is 100. So it's very same. A's income x minus mean is divided by the standard deviation 70. That is 3. So this is the A's income. So that is A's income. And the B is x x is the A's income. So let's talk about the A's income here. And this is the B's income, and the mean is 400 here. 400. Oh, I mean the division. Yeah. It's very inconvenient that I cannot use the annotation here. And the standard deviation is 100. So that is 5. So that is the X in the bottom is B's income. So let's calculate. In this case, we can know that 70 can be moved to here. So 70 multiplied by 3 is X minus 500. So X minus 500 is 210 because 3 multiplied by 7 is here. And then in this case, X is 710. So that's A's income. In the same way, X minus 400, that is 500. So X is 900 as B's income. So we can say that B's income is higher than A's income. So let's see whether we are right. Okay, that's great. So the z-score is 1. So I made a calculation process here, so you can review later. And then 285, that's the answer. And the samely, this equation, and then 701 and 900. So these are the answers of the calculation. All right, so these are mostly about the very basics of the z-score. And I think we will cover more about the z-score. I mean, how to find and how to use the z-score distribution and how to use the table of the z distribution to find the proportion between some specific numbers, because we were using the pre-identified. So I mean pre-identified numbers as only one standard deviation, using 2 standard deviation and 3 standard deviations. So we just couldn't know the 68, 95 as 99 as the preoccupied numbers. But there should be some other numbers like when the z-score is 1.753 and another z-score is negative 1.5, and then what would be the proportion between them? So these will be the big part of the z-score transformation, and which is directly relevant to the question number 3 in the question number 3 in the level assignment 2. So these will be covered by the class next Tuesday. So before that, maybe you can review this video again and try to answer question number 1 in question number 1 in the level assignment 2. So these are mostly about the question number 1 in the level assignment. Alright, so thank you for watching this video, and hopefully stay warm, and because there will be many possible issues with the blackout, and some of my friends in the Houston, in the Texas, they lost their water supply, and that might be very bad. So stay safe and stay warm, and see you next Tuesday in synchronous lecture. All right, thank you for your time and have a great weekend. Bye bye.